Example 1. You want to build a rectangular fence with 2 pens next to a river. You have 200 feet of fence. What are the dimensions that will give you the largest area? How am I going to find this? My answer is going to be the global maximum of the function, but I must come up with the correct function. I always know it's going to be the global max or the global min. So, given that, let's start by drawing our situation. Okay, let's say we have a river, and you're going to build a pen, fenced-in area next to that river that's in the shape of a rectangle. I'm not making any assumptions at all about its dimensions. And you want it to have 2 pens. So we're going to put a pen in the middle, and it doesn't matter where we put it. So, what are the dimensions? Well, let's let x be the length of our vertical sides and y be the length of the horizontal side. Now, here's a few facts that I know. If we're looking at the area of this object, area will equal x times y. That's one fact that I have. Another fact, problem is this is an equation in 3 variables, and step 1 was to make an equation in 2 variables. So I need to get it down to 2 variables. Generally going to use substitution as our main tool, but not exclusive. Earlier in the word problem, it was given that we have 200 feet of fence. So let's talk about the actual fence we're going to use. We're going to use one x length here. This will be a second x length, and this is the third x length. So we will have 3 lengths of x plus 1 length of y will give me a total of 200 feet. That's all I have. I can use this equation to either eliminate x or y from the original equation with substitution. So I'm going to solve for y. Oops, that's 3x. And use it as my area formula. So now I have area equals x times y. I'm going to use a distributive property here to simplify this. And now I'm going to talk about the domain. Okay, domain. That's how much x fence is available for fencing used on x. Okay, so first of all, we're going to use 3 pieces of x. So the smallest amount is clearly 0. I have 200 feet of fence, but x cannot be 200 because every time I'm using one piece of x, I have to use it 2 times again. So the most, let's assume y is 0, then the most x can be is 200 divided by 3. So my domain is 0 to 200 thirds. And I'm going to leave it as an exact value. It's easier for finding global mins and max. Now, next step. I have my end values on my interval. I have a continuous function, because this is a parabola, which you know is continuous from negative infinity to positive infinity. I'm going to take the derivative and I'm going to set it equal to 0 to find the critical points. So I'm going to add 6x to both sides and divide both sides by 6. 200 over 6 reduces to 100 over 3. Oh, my pen's getting a little wacky. Okay, so is this critical number between these two numbers? And the answer is yes. So either using 0 feet of x of fence will give me the largest area, or 200 over 3 feet of fence for x will give me the largest area, or my critical number, 100 over 3, will give me the largest area. This is guaranteed. So let's find out. I'm just going to use my calculator. X and area. I'm going to plug in 0, 100 over 3, my critical number, and 200 over 3, my other endpoint. Using my graphing calculator, if you would like to. And I'm going to turn it on. Coming on. Oh, let me turn it off and then turn it back on. Sometimes it gets a little glitchy. So, area, I'm going to first store 0, store it as x, and my area is 200x minus 3x squared. So when I plug in 0 for here, clearly you should see that we're going to get 0. So when I don't use any of it for x, then my area is 0. I'm going to plug in my other endpoint, which was 200 over 3. Store as x, enter, second function entry, second function enter. And when I plug in 100 over 3 for x, again, I get an area that is 0. We're hoping the maximum area is going to come when I plug in that 100 over 3. So let's do that. Click the wrong thing. 100 over 3, store as x, enter, second function enter, second function enter, takes me back, and enter. 3,333 as a fraction, just in case you want to see it as an exact value. Oops, didn't work. Not sure why, but I'll leave it as that. 3,333.33. I'm guessing repeating. So, let's make sure we've answered the question now. We know that 100 over 3x value will give me the largest, but the question is, what are the dimensions that will give me the largest? So, x we know is 100 over 3. That's going to give me the largest. Let's find the y value. How am I going to find the y value? Substitution. And y is 200 minus 100. Oops, again, get a little weird. The largest area that I can make along a river, building a rectangular fence with 2 pins, will have a dimension of 100 feet and 100 over 3 feet, which is 33 1/3 feet. Hopefully this made sense to you.